Okay, sure. I'll start. My name is Forrester Cole. I'm a software engineer in the machine perception group here in Cambridge, and I work on machine vision. Most recently, if you saw the talk this morning, on depth prediction for mobile applications.
My name's Hallie Crosby. I am on the machine learning customer engineer team, focusing mainly on manufacturing and healthcare accounts.
Hi, I'm Daniel Smilkov. I'm a software engineer here in this office, working on TensorFlow.js, so machine learning and JavaScript.
I'm David Belanger. I'm on the Google Brain team, and I do a variety of machine learning things, mostly focused on life science applications.
Open to any questions from the audience. So if you want, go ahead and queue up. If not, I can kick. I have a couple questions lined up, but feel free to start queuing up. We can go ahead and start with the first one, and this is for any or all of you. What is the most challenging project you've worked on? Throwing a zinger out there first. Go ahead.
So it's always the last project.
I was going to say the
because
same
project grow in complexity, or obviously if you're like, as my career has progressed at Google, projects do get larger in scope. So it always feels like the latest project is the one that is the most complex one. So for me, that would be TensorFlow.js, just because it has so many moving parts beyond being a library, understanding users, understanding JS developers, dealing with issues like, is ML ready for prime time so JS developers can just use it in real world applications? All sorts of interesting questions show up beyond just technical challenges.
Yeah, I mean, in research, it kind of better be the last one, because I mean, if it isn't, then you're not working hard enough, I think. But yeah, I agree with that, and then especially with sort of machine learning research, the field is moving so fast that even just keeping up with what's going on is sort of a job in and of itself, and that gets harder over time as more researchers come into the field.
I don't want to ask all the questions, so if there's any others. So I did overhear some conversation during one of the breaks asking questions about the healthcare space. So this question would be for you, Hallie. What does Google do or provide to protect against HIPAA and the security around patient data?
Yeah, so I guess the question wouldn't be what does Google do for healthcare, but I think Google doesn't have a HIPAA cloud and a normal cloud, right? So we have one cloud. You don't have to choose between protecting data and not protecting data. So that's one and the same. So when we think about data, we automatically consider these things that would be considered HIPAA violations for the entire cloud and for all industries.
Hi, thanks for all of the talks today. They were really interesting, and I think I learned a lot today. I have one question that is not specific to any of the topics that you spoke to directly, but more and more we're seeing that governments are relying on big tech companies to advise them or help influence the way that people interact with the world, how people perceive the world, how they're being informed about either their health or safety or their information and data. How do you see ML and the work that you're doing impact, I guess, how we interact with everyone and everything in our daily lives?
I mean, that's a big question with a lot of answers. And it's something to be taken very seriously, and I think Google takes very seriously in that if we are sort of the window between people and the information, then if you're introducing machine learning into this, there's all sorts of biases that can be introduced into what information is being given to what people and stuff like that. And so it's really challenging, in particular because machine learning is very good at generalizing from what it's seen so far, but oftentimes we're charged with changing the status quo, not just reflecting it. And there's a lot of like very concrete work at Google on how to make machine learning fair for these sorts of applications.
So I write curriculum teaching high schoolers AI. So what I'm always interested in is if you had an audience of high schoolers, what do you think would be the important thing for people to know about AI, how it works, what you do, how to become you guys?
I would say try out one of the TensorFlow.js demos. There is one. No, seriously. So there's like an amazing, one of the earliest applications built with TensorFlow.js was this project called Teachable Machine. And it allows for anyone of any age to interact directly with a machine learning model and train it on the fly, where you can give it your hand and different poses and associate it with different actions. And I think it's really useful. And those kinds of demos, I think, are really amazing at trying to understand machine learning at a more conceptual level. And I think that's a great start because it feels like a game, it feels interactive. So any of those kinds of things. I know that Scratch, which is a project from MIT, is also a really cool thing. And I know that they are working on integrating some of the machine learning blocks into their block building stuff. So that might be also cool to check it out. Teachable Machine. You can Google it. It's one of the Chrome experiments, I think.
My question actually may be very specific. In healthcare, there are a group of, basically one topic of problem is to predict risk for patients. Model we often see, it seems like always have a fixed time, like 6 months risk, 12 months risk, 1 year risk seems the most common models. I've been thinking, is there some type of models can achieve, given any time, give a risk prediction? Or like often the one way to achieve similar things is basically to fix a lot of time and create a bunch of models and then light them up. I'm wondering, in general, does any machine learning or traditional model serve that naturally?
I guess there's two answers. One is like sort of statistically how one would model such data, and the other is would that be a model that we would want to pursue? And so the first thing, you could have it as a, rather than having a classification task, is this person going to have this outcome in the next 6 months or whatever, you could have some regression task, which is predicting the amount of time until they have a certain outcome, right? And then it has this flexibility that you can ask various questions of the model in terms of partitions in time. I think in terms of clinical applications, like there is a sort of a specific horizon beyond which it's very challenging to make predictions because things there's a lot of stuff that can happen to a person, and so I expect that most of the clinical applications have fairly short time horizons because that's where you can actually have like a clinical meaningful decision based on that outcome.
Okay, thank you.
Hi, my name's Sarah. I'm interested in, for Daniel, your work with TensorFlow.js. At Google I/O, they had one talk.
Sorry, do you mind speaking into the mic?
Sure. So, my name's Sarah, and I had a question for Daniel. You've been working on the TensorFlow.js, which and mentioned something about from the privacy side, which I thought was about federated learning, keeping data on the devices and embedded, and then sort of scrambling it and sending the relevant information to be learned and advancing the model in the cloud. So I'm wondering, with that and other things that the people in AI research group is doing, like the what if tool that we heard about today. Unfortunately, I did not get to see that talk. I'm very sad. I'll look it up online. But how easy are you making it for people who will just be picking up these tools to to make sure that there is privacy and there is, how easy are you making it so that people picking up these tools will add privacy and fairness into their package when they incorporate ML into their product? What reality would you say on how easy and attractive and realistic it will be that people will be using it?
Yeah, so I think it's, to make something really easy to use takes a long time. And there's a lot of iterations. And then what does it mean to make it easy? Also there's multiple levels, hierarchical levels. So I think both the What If tool and TensorFlow.js and libraries around it are going through that progression of being easier and easier as higher level things are being built. I know that for What If tool, it used to be part of TensorBoard, so if you're running and training a TensorFlow model, you could load it in TensorBoard and visualize. But then a lot of people just wanted to understand their data. So nowadays there's Colab notebooks and IPython notebooks and much easier wrappers where the What If tool can inject its UI directly in the notebook output. So I think that we're always pushing the limit on usability. And then there's what I like about the What If tool is publicly there's workflows and there's use cases that have been shared publicly that demonstrate how you can explore this tool. And I think with TensorFlow.js and federated learning, we had interns a couple summers, like last summer, that worked on a library around TensorFlow.js to do federated learning. So it's an intern project. You can go check it out on GitHub, pair-code/federated learning. Pair code is the GitHub repo for all the people in AI pair-related projects. But it's an intern project. They did some experiments for 3 months. It's not production ready. Obviously, to make something privacy preserving, there's a lot more to be done. And Google actually has, by Google I mean outside of TensorFlow.js, there is a federated learning library to do more enterprise level training.
Okay. I guess on a personal opinion sort of way, since Google is doing a lot of on all the different products, reaching out to democratize ML, and what would your opinion be in when you make ML go viral? Will there be some cost if the tools aren't built into it, or sort of precautions aren't built into it to prevent some sort of bias inducing sort of things, mainly bias or privacy concerns?
Yeah, I mean, I think that's a huge concern, and it's something that we're definitely aware of. And one way to get around that is to not treat machine learning as just a black box where you dump data in and you get this black box classifier out, but instead provide an ecosystem where people can visualize the inputs and outputs of their model and do a lot of probing of it to make sure that it's consistent with what they think should be happening. So I don't think the solution should be this really elegant high-level library that just gives you a classifier. And this What If tool, I think, is a great example of the right way to do it. And I think I would go a step farther that it's really important to think about the data collection process, where the data came from and what sort of bias was introduced in the distribution from which it was sampled. And that's, I think, something that may not be sort of in the thought process of certain people that are new to the field, just because they might not think of it as sort of a statistical learning problem. And that's something that's on us to really teach people about the hazards of that.
Yeah, and I'd have to agree. I don't think you would want even someone like Google to create a tool that provides this blanket guidance, right? You wouldn't want to put that sole social responsibility in the hands of Google. So you need to take the responsibility as a data scientist in yourself to make sure that these checks and balances are in your models. It shouldn't just be one overarching organization or person guiding what is right and wrong. It should be a collective.
Hi. So a couple of general questions that I was really curious about. in the field like ML and AI in general, which is like so rapidly changing, how do you guys like, how difficult is it for you guys sitting inside and working to focus on the project at hand when you know that there is new research or new libraries being like, developed every day? So how do you try manage to find the balance? Like, do you focus on your project in general, or is it like, for example, you've used some embedding technique in your research project, and today some new thing comes out? So do you like rush and just try out the better one, or how is it? This, and number two is like, with such craze behind state of the arts, right? Is there an additional I don't know, pressure on you guys? Like, so suppose someone else's publishes a new research, and then you guys, which you had the state of the art currently. So does the pressure mount on you guys, like, even though you sacrifice some of the part, so that you reduce the time to publish the next set of research, something like this?
I think it is. Yeah, it's hard. There's just like, if I get these archive digest emails, which is basically archives where everybody's throwing up these papers, and every day there's probably like 2 papers that I feel like are quite directly relevant to work that I'm doing, just thrown up there. But I don't think there's a one answer to that question. That's just like walking that line is kind of, how much time do you spend doing your own thing, and how much do you spend figuring out what else is out there, is just sort of a case-by-case basis, I think. Like, if something really excites you, then maybe you just sort of drop everything and look at it. But that happened a couple months ago. But otherwise, no, keep going on what you're doing. At least that's sort of the way I do it. I guess, what was the second question again?
So the competition, does it add more pressure to like push your research faster, or is it like?
I think actually it's harder on academics than on us, because we don't necessarily live and die by like one paper the way that someone in an academic position might. But I don't know if
Thank you
people
so
have
much.
different positions.
Yeah, I'll just add, in my role, it's companies coming to us asking advice on these type of things, right? So what tool is best? And while I don't have to kind of stop a project and say, do I need to change the direction of my project because of this new technology, I'm sort of responsible for making sure that I'm advising in the right path. So I do try and stay at least knowledgeable of the basic terminology and concepts that are coming out, but you have to keep moving forward with what you know, and you can't put all the pressure on yourself to understand every technology in ML. Maybe working at Google is a little easier because you just only concern yourself with what Google puts out, maybe. So it's a little easier, but yeah, you can't take on that responsibility all to yourself.
I would argue that another way to avoid the stress of the archive is to really focus on solving a problem rather than advancing some methodological improvement. So the machine learning community, I really dislike how much focus there is on methods. And so all the top machine learning venues, you have to have methodological novelty. It can't be like, we apply machine learning to this super important problem using like a linear classifier and we got good performance. And so if you have a task where it's like, I tried the fancy thing, I tried the simple thing, and it turns out the simple thing did better, you want a situation where that's a success story and not a failure, right? And so I just encourage you to not get too caught up in the craze around methods and really just dig into some problems.
And so I guess my question is slightly related to the last one. So my name is Victor. So it's related to the amount of effort that's associated with a typical research cycle. So for example, the project in identifying depth information, how long does a project like that take? Is it a 3-month project? Is it a 6-month project? Is it a 3-man team, a 5-man team, or a 1-man team? Yeah, what does that space look like? And when you're done with that, there's also, you need to write the paper, right? And so there's all that pain there. And then finally, you need to create the software, right? So yeah, what does that landscape look like for you guys?
I guess I can talk about that project and specifically. It's hard to sort of say where starts and ends because everything is always building on the last result. So for that project, we already had this infrastructure to do data mining in place, but it was 6 months, I guess, from the time that we started doing that particular subject to the time that we sort of wrapped it in terms of a CVPR paper submission.
I see. Daniel, David.
I mean, yeah, I think that one thing that I've struggled with lately is that like big projects that are ambitious require a time scale where you don't have these intermediate checkpoints like defined by papers. And that can be really challenging because people are young in their careers and their progress is often measured in terms of paper authorship and stuff like that. And so I think it's really important to sort of have protocols for a team where everybody's on the same page about what their goals are, and like that you really want to invest in like really good software and slow things down and make sure everything's tested. And that just requires like a cultural shift.
Right.
And so the project I'm working on now, this is actually like there's a lot of tension around this because different people have different priorities in terms of that.
Right. Cool. Thanks.
Hi. So I guess my question is specifically for life sciences, and I'm in the medical field in particular, but I guess I'm interested in hearing what from all of you. So one problem that we've been dealing with is that our data sets are only as good as what we can collect, and we have limited resources for collecting a lot of data. Now, there's this other problem of where, especially in medicine, you don't want to introduce too much bias because then none of your therapies or whatever is going to work for the general populace, which is the kind of the gold standard. So given that, I was wondering what your strategies were for basically expanding your data set, given that especially in medicine, everyone kind of has their own data sets and are keeping very tight controls over him because that's, in a way, currency. So I was wondering, what kind of strategies have you guys used in order to basically expand your data set across, maybe state lines or national borders, or like, so we've tried contacting a lot of public health groups, but they're kind of not interested in necessarily sharing a lot of data for machine learning purposes. I was wondering, where have you guys managed to kind of solve some of those issues?
Have we done any of us up here done life sciences stuff, medical data?
I mean, I talked about life science stuff, but it was all very much like very specific collaborations or public data. And I think what you're describing is super challenging. Yeah.
Yeah, I would second that. It feels challenging because it is challenging. We haven't solved that. I know there are some times where we want to build something, but we don't have the data to do that, even as Google, because it is, like you said, currency. What I have seen in customers is strong partnerships where you're using that data as currency. I give you my currency, you give me your currency. And then when all of those routes fail, I would say in the healthcare space, there's a lot more opportunities to collect and gather data that maybe isn't currently being used to collect and gather data. I would say it's kind of like when you build a machine learning model, is it the model or is it the data? It's usually further back in the problems in the data. Maybe here you're kind of coming up on an issue of we don't have enough data. Maybe go back to your sources. You probably can find some opportunities, probably have to jump through some hoops, probably get some extra forms signed, but that might be the next step to go.
Yeah, are you aware of any efforts to like kind of create an organization that kind of would handle that and kind of facilitate that? I'm coming at this from a software engineer perspective, so it's like this level of not being able to see what other people are kind of doing and talk about it is new to me. So that's kind of why I'm asking this question.
I'm aware of at least some efforts, I think maybe in Stanford, not at Google, to try to sort of create an infrastructure for sharing this sort of data in a privacy-preserving way, and that can maybe be helpful in some of these negotiations on it. The that's a technical thing that we may be difficult to explain to people who are reticent to share their data, but it's something I think it's called CARA, or maybe it's to look into.
CARA or
KARA.
KARA? Okay. Thanks.
There's also a lot of work on creating statistically significant synthetic data from your current data. So say that you know that in your patient subset, 50 people have melanoma, then you're able to generate synthetic patients based on the statistic sample of the patients you know you do have, if that makes sense. But I'm not sure if that's public either.
One issue that we ran into is that basically, if you have to go to the FDA with anything, they don't like synthetic data. They want real people. So that's one of our barriers, and we've had a hard time getting over that. We basically just need to. It sounds like we just need to up our data collection efforts or partner with somebody who has what we're looking for.
There's also just the general sort of data analysis idea of like, do you have not enough data or not representative data? Like,
not representative.
all right,
Yeah.
so then you're in more trouble. Sorry.
Yeah. Okay. Thanks. That's what I thought.
Hi. According to me, you are a great machine learning artist, and recently published paper, according to recently published white paper, government-based regulation will be the most important obstacles for that creation process. So what is your biggest fear about that government or state-related regulations? And what if Google hit that wall one day? What will be the solution?
Sorry, regulation of so did you say data collection or?
I mean, I'm giving from my country. 1 year ago, it's open to take the pictures of the students inside of the classroom, and we try to detect their motivation. And after 1 year, they banned everything. You can't collect any data, and you can't predict any motivational thing in the country. They said, and we didn't do anything. And if you hit something like that, I mean, what is, in your research area, what is your biggest fear about government-based regulation?
I mean, it can certainly make our jobs harder, I think, to sort of limit the sort of data that we're allowed to use. But honestly, this is sort of strange to say, but from a technical standpoint, it's almost more interesting. Like the supervised learning of using personal information has always felt a little weird. And so if you're just not allowed to use it, you have to come up with some other technical solution, which there are a lot of, and these privacy-preserving methods are starting to sort of be developed that can handle some of those situations. I think that the biggest fear would be some regulation to me that doesn't kind of understand the key issues as we see them, and sort of heavy-handed and stopping things that don't really make sense from a technical point of view. But.
Hi, my question is, what's your opinion on the future of AutoML? And so I'm a machine learning engineer. Do you think I will lose my job in, say, 10 years? Or do you have any career advice for people like me working on data science and machine learning? Thanks.
If you lose your job, we lose our jobs.
Yeah, I wouldn't worry about it. I think that, yes, like software will always get better, and there's certain things that'll get easier, and that's certainly happened. I mean, deep learning has made a lot of things easier because there's just this unified language for a lot of different application domains, right? So it's much easier to like share code between NLP people and computer vision people now and stuff like that. First of all, so maybe there are some like sort of software, like boilerplate software things that'll go away, but the like rigorous poking and prodding of a model is something that is going to be ever more important. And so building tools for like maybe detecting that, the data that's coming into your machine learning model in production this week is qualitatively different than it happened last week, and therefore you shouldn't be trusting your model's predictions. Like, that's super important, right? And so as we sort of ratchet up our understanding of ML, we're also ratcheting up our mistrust of certain deployments of it, and there'll be a lot of sort of software challenges around knowing when to trust and when not, and stuff like that. So you're in good hands. Yeah.
I had a chance to play with AutoML a bit in the last month, training some models for image classification and object detection, just to learn a little bit, because even though I'm at Google, Google is big, and we sometimes have to learn, keep up with everything that's happening. And I think it was, I really like AutoML from one point of view, and that is because I didn't have to spend time debugging Python or figuring out shapes, compatibility, or some other bug, then it focuses you on what actually matters, which is the periphery, which is the output and the data. So it was really interesting that once I plugged in some images, this was all like a sample project, basically. It was like a fun project. And the model got trained, and I got an email back a couple hours later. The only questions I had were, how good is this model, and where does it perform poorly, and what can I do to make it not perform poorly? And it's interesting because once you have this constraint of I can't touch and play with the architecture or the hyperparameters, the only thing that you think then is like, how can I collect more data to be representative for some subset of the population or something? Or how can I analyze this model on the output side? Is it doing well? Is it its accuracy along some axes okay or not? So I think it will be great if we can solve the problem of writing Python and writing these architectures and doing tweaks of the parameters and focus on what actually matters in the long term, which is understanding its implications, the output and all the data and representation and all sorts of stuff.
Yeah, so I completely agree with Daniel. And one thing I would say is maybe the nature of your job will change, right? So when you go to Google Next, you hear about democratizing AI with AutoML, making it easier. There are still going to be these, even today, unforeseen problems that we're going to want to solve with machine learning that AutoML is simply not going to address. Like today, AutoML only works if a human can label that image in under 2 seconds. If a human can't do that, then it's not going to perform very well in AutoML. So there's still huge ways to go with AutoML, and there'll be other problem domains that you will need humans, data scientists, researchers to solve. And I think on the ML engineer side, there's always going to be the need for CI/CD, integration, deployment, productionizing your models. So I just think the nature of the job will change. And just not to go back on what we said earlier about not keeping up with all the new technologies, but don't be afraid to learn new things as you go to make sure you're not sort of stuck in your ways.
All right, thank you.
Hallie, what would you say to a large financial institution who's interested in GCP products, but is highly regulated and has a lot of constraints around privacy and security?
Talk to my colleague, Drew. No, we have people on my team who work solely with financial customers and are in the project manager's ears going, we can't use this product because of this. So the next iteration, it is applicable to financial customers. We have a team that's dedicated strictly to fintech and making sure that our products meet your requirements, which I think are probably more stringent than healthcare requirements. So yes, we are dealing with it. There is a space for you to get started. Yeah, we're here for you.
Thanks.
Okay. Sorry. Which areas are you really excited about in deep learning also that you think will be revolutionary in the future? And also, my second question, like, how do you feel working at Google? Like, I know some of you are research scientists, software engineers. Like, it's such a big company. I don't know, how much impact can you make? Like, how do you, I know you guys are super smart guys, super smart ladies and guys, but how do you feel working at Google? And do you feel like what you do really makes an impact? Thanks.
To address the first question, I'm really excited for us to finally solve the self-driving cars so we can start working on healthcare problems more seriously and free up some resources for that. Once we have self-driving cars, there'll be more healthcare problems solved. And working at Google, that's a valid concern. Definitely before taking the job at Google, I had the opportunity to work at a smaller company where there's lots of low-hanging fruit. You could accomplish things and sort of be the star. But I think it's just a personal decision you have to decide on. And maybe the free food helped to make that decision. I don't know if you guys have.
Yeah, in terms of ML areas, I would argue that, so like big data is this term that people think is very hot right now, but I would argue that that's boring, and small data is really where it's at. Like, if you have a lot of data, you just like throw a big model at it and it's fine. But if you have a small amount of data, what you need to do is show up to the table with some prior knowledge that's gonna allow you to generalize from few examples, right? And that's really, really hard, and it requires knowing the domain well. And also, oftentimes the prior knowledge isn't something that's easy to inject into the problem. It could be that like you have an expert that you could tap on their shoulder and ask them questions of, but how do you like make that into some numbers in your model, right? And so oftentimes there might be some unsupervised learning you do in advance, and then you also talk to some people and they help you with that. But I think that sort of, especially in these applications that I look at, it's this situation where you have like huge amounts of data and that are like related a little bit to your problem, and then you have like 5 training examples for some other thing, and that's a cool regime to be in. So yeah, and this occurs in tons of applications. But I mean, also I think like machine learning is just it's just ratcheting up. Like the things we're looking at are just getting harder and harder. So it used to be that like supervised learning was the thing, and now it's like supervised learning is kind of solved. And now we're thinking about like reinforcement learning and these like bandit applications and things where there's a lot more reasoning under uncertainty, and those oftentimes don't actually intersect well with what helped us solve supervised learning. So deep learning is really cool, but it makes it a lot harder to reason about the model and like, for example, be like Bayesian about our model and think about sort of where to trust it and where not to trust it and stuff like that. So there's a lot of just like hard stuff out there. We certainly haven't solved it.
Thanks.
Cool. So I actually have 2 things to curious to get your thoughts on. One's like when you're doing research, how do you prioritize and figure out what is the ROI for the different potential approaches so you can make the most amount of progress the quickest, right? And then the second problem is after you did that research and it's working, like what are some of the best practices that you've put in place that was helpful in terms of like getting that research into production? Because I work for a lab that recently became a startup and now that's a problem. So feel free to answer whichever one you feel strongly about.
I mean, one thing that we've really struggled with is how fast to go. So sometimes you want to just like, throw some things together and get some quick results and demonstrate some stuff. And then other times you want to, like really slow it down, write really careful tests, analyze everything. And generally, I would argue that the second mode is faster in the long run, but it just requires sort of a lot of infrastructure around that. And so on the team I'm on now, there's people that just came in with like a pure software engineering background that were just like horrified by how sloppy some of us like fancy PhD people were doing things. And like that culture, I think, has actually really helped us overall.
I guess in terms of choosing research problems, I mean, Google is sort of a nice enough place to work that we pretty much work on stuff that we're excited about. Like, it's just ask the question, do I want to work on this? And then you sort of have to narrow that down to stuff that Google might possibly care about. But Google being such a big company, that's a pretty big space.
So if I may ask a follow-up, like, let's say you define the problem you care about, and there's maybe like 3 or 4 different approaches, but you don't know which one's likely to work, then what is the next like step so you can like kind of have a prioritized ranking of what's more likely to work for the amount of effort and stuff like that? What is your process like?
I think it's essentially what you described, and then you try them in that order, and there's some sort of moment where you decide, and this is based on experience, like, this just isn't going to work. I'm going to move on to the next target. And that's hard to describe, sorry. It's just like, if you feel like you're beating your head against the wall for 2 weeks, you probably stop.
That's a good rule, thanks.
I forget who said this, but there's also this like fundamental idea that if you have some like new fancy idea, or you like read a new fancy paper and you're like, oh, this seems like a perfect fit for my application, just take the paper, go to whatever their like table of results is, find the baseline method, implement that. Because it's like definitely actually more like battle tested by the community, and probably like the fanciness is not worth the overhead. So another way to say this is like you shouldn't shape your research project around doing something cool and then writing like a related work section at the very end before you submit a paper. That should be the first thing you do, and you should be like implementing those things before you even like consider doing something that's like methodologically novel, because there's a lot of people around that have thought a lot about these things, and you should be drawing on that.
Awesome, thanks.
Hi, I'm just curious what your thoughts are on the role of causality in ML. So if you want to make like a caricature of like an ML algorithm or a problem, right? Like you basically take some images, take some features, throw like a big model at it. At the end, you basically get a result like cancer, no cancer, right? Like, but you've really not established any kind of like what are the causal things that are happening in your data set that basically lead to this outcome. Even when you're doing things like the what if tool, you're still like not really establishing the causal link. So do you see a role for maybe having some kind of like forced directional graphs in there, or just try to understand causality more generally when we do ML?
I've kind of lost faith in that approach, to be honest. Like, I think when I started working in this field, I was like very interested in this. I want to understand what this model is doing. And now the way I think about it is like, okay, if I could visualize a million-dimensional space, it would just be obvious. Like the way that it would be obvious if I would see it in 3D. But I can't. And I don't know if there's really, in general, a better way to go, even that's going to simplify it without losing what makes it actually work.
Yeah, I think a lot of these causal things really rely on having like the underlying model that you fit the data, and if there's any sort of misspecification, then that could actually be quite dangerous, right? And so I think the like ML community, I think we have a healthy approach to it, which is that we're not making any claims of sort of understanding the causal mechanism, and the way that we're interacting with the model isn't expecting that. That might be safer than fitting a causal model that's like slightly misspecified and then making conclusions based on that.
Yeah, thank you so much.
Thank you all very, very much. So please get up for Forrester, Hallie, Daniel, and David. Thank you all so much. Yes.